Hey everyone, so in this video I'm going to talk a little bit about C programming, especially in the Arduino. So you have some idea how to get the labs done because some of them will require you to program. It's not very difficult, however, it does require a bit of practice and knowledge. So starting with the most basic things, we have how to include. So let's go ahead and look at how that works. So include basically tells your sketch, or let's say Arduino example, or whatever you're writing, that you want to include a particular library. Now usually if you want to just blink an LED or do something like that, you don't really require to include these libraries. However, there are some specific functions for which you have to have those libraries. One of them is I squared C communication, and the library for that is known as wire. So you can go ahead and type something like hash include and wire dot h, and this will give me access to all of the functionalities that are included in this library. So there are tons of such libraries out there, and you might have to include them from time to time depending on what sensor you are using or what output device you are using. For example, if you want to use the servo motors, then you will have to include servo.h, and this will give your Arduino and the program the ability to control the servo motors using the functions that are already written and implemented in this library itself. So for example, let me show you one of the codes I have wrote, and should be right over here. So as you can see, I have included three libraries: wire.h, software serial.h, and sparkfun MMA8452q.h. Now you might have noticed right over here that wire.h and software serial, they both have this kind of guards against them. However, this one has not. It is in double inverted comma. Now why? So in standard C, if you have some system included libraries, then you use these signs. For if you have some library, let's say called abc.h, which is already provided to you by the system, and by system I mean in here Arduino IDE. You just go like abc.h and you just close it. Now obviously it is not able to find any such thing, and therefore it is not highlighted. However, it basically tells the compiler that okay, this library is something that you can find in installation folder of Arduino, or whatever the default library folder is. On the other hand, if you go for the double inverted comma this and you write abc.h, it basically tells the compiler that okay, this is a non-standard library. Non-standard as in the Arduino hasn't provided it like by default. However, it is something external or something that is installed, and it is like an external component to your system. So that is the difference. So always remember that when you have downloaded some of the libraries, you might have to include them this way compared to some standard ways, and the best way to know about it is to just open the examples. For let's for an instance see that if I want to use pi interface, I'll just open this and look at the include, and as you can see, it is by default system provided functionality. However, if I want to check out something that is to do with the accelerometer, I'll go and open any example, And sorry, these windows are really small by default. Anyway, as you can see, they have this double inverted comma. So if you want to use any component and you have just downloaded the library, just look at the example first. Now talking about our next subject is define. So as you can see right over here, there are some hash define statements. Now what it does, it basically defines a constant or a macro. So a macro is, you can say, a really short function that you can write by just going like this, hash define. Because the thing is, if you write a function all by yourself, um, it is not necessarily slow in every single setups. However, the macros are always in advantages compared to user defined functions, because they are kind of known to the compiler. And when you look at the assembly code, which is quite deep level actually, but the macros always have advantage over the functions. And if you have just like one line function, it's better to do just this than to go something like, okay, void and then function one, and then you are passing arguments here, and then you have to write the entire thing. And if you want to return something, it wouldn't be void again. For example, if you want to return float, let's just say float function one, and the input is again a float, so just float here, and you'll have to write something like return and then argument cross whatever that is, put it there, and this. So you had to like write 4 lines compared to just one in here. So that's the advantage of macro, and there are other advantages as well, which I will not talk about since they are not directly related to the course. So anyway, that's about the macros. And for the defines, you can define any constant in here. For example, I have defined id of angle 1 as just 1, id of angle 2 as 2, then offset that I'm using somewhere in my code as 90. And so the things you are seeing right next to it is what called typecasting. So before we get to the typecasting, let's talk about some data types. So there are few basic data types in C. For example, there is integer, there is float, there is double, let's say double C. So these three are like most basic ones. And sorry, four, I forgot a character. So these 4 types. Now I won't go into much information right over here, but the basic idea is character is something that you use to hold ASCII characters. For example, ASCII of A or B or C, something like that. Integer is again just integer numbers, and it has negative numbers as well. Float is something for floating point numbers, and double is also a floating point number, but it has more precision than a float. And so these are the standard data types. However, as you can see, there are something called uint 8 underscore t and such things. So the problem with standard data types, for example integer, is that you will not know that what compiler interprets of that. So for example, if I'm running a 64-bit operating system and 64-bit architecture as well, then this integer might even mean that the A will be something that has 64 bits, and that can throw off my calculations if I'm assuming that A has 32 bits, not 64, right? So if you want to tell compiler that I want exactly this many bits, there are few techniques. For example, if you type uint 8t and abc, then now abc variable is basically that has 8 bits, and it is being interpreted as unsigned. U stands for unsigned, so unsigned integer with 8 bits, and that's abc. If I go like int 8 underscore tabc, then it still has 8 bit. However, the most significant bit will be indicating sign, whether it is a positive number or a negative one. So that's the difference between uint and int, and that goes the same way for others. For example, there's uint 16t, there's uint 32t, and there is uint 64t as well. Most probably we will be using uint 32t and uint 8t because they are the most common ones, and as you can probably understand, the 32t is useful because it gives you 4 bytes, which is very useful, and 8t is because it's just 1 byte, so you can align this anywhere. So these are the basic data types that you will be using a lot for any kind of programming in general. However, these uint ones, speak they are kind of more used in the embedded world than the pure computer science, because in the embedded systems you have to know how many bits and bytes a specific part of code is going to hold, so that you can estimate the behavior. So we'll get rid of those right now. Anyway, the next topic would be, let me check. So we have concluded, so we have gone through includes and defines and data types and variables as well. Variables is just kind of an object, you can say, that can hold multiple values. For example, I have float xlx right over here, which is a short form for acceleration in x-axis, and I can assign that few things. As you can see over here, I have just got a return value from a function, and I just stored that in that variable, and on another point I'm using that variable to calculate something, store it in another variable, and it keeps on going like that. So it is basically an object that can store result, and based on the data type, the result is something that will have a few number of bits. After variables, typecasting. So typecasting is something that you can see right over here. As I said before, this is a typecasting. Typecasting is very important in Arduino and in C overall, because what it tells the compiler that force this or treat this value as a variable of this type. Now, for example, if I write hash define and let's say tmp1 or whatever, and I just write there 56. Okay, now this 56 by default in most compilers will be interpreted as an integer. However, sometimes that is not the case. You cannot say with 100% certainty that if you just type a variable like this, what it will be interpreted in the system itself. So therefore it is always a great idea to typecast all of your defines and all of the variables as well. Now in the case of for example, let's say variable 1, or let's say we have like temp1 right over here, it is already float. But if I am storing something in there from let's say integer or sign double or something like that, I might have to tell the compiler that okay, force this specific variable into this form. That is very handy when you are converting a float into integer, because without the typecasting you might get some overflow and incorrect results, and it's just bad practice to have that. So for example, if I have, let's say, float tmp1, and I have, let's say, integer tmp2, and if I'm doing something like tmp2 equal to tmp1 cross something like 567, now in this case I should be typecasting everything. For example, I want this float to be treated as integer, then I should type just like this. I want this to be treated as integer, so I'll just go like this. Sometimes you don't care about the individual variables, but you do care about the overall result. So in that case, typecasting works just like that. And typecasting is just really important, and especially when you are converting from one kind of variable to another one, it is always good to have it. I'll just remove this for now. So as you can see right over here, I have lots of defines, and all of them are typecasted just for safety. For example, if I remove this right over here, my code will work, no doubt, but in some specific cases it might just break, and if I don't want that, it's just a safeguard to have this right over here. Same goes with this 1 and 2 and everything. So always remember, especially in the Arduino, that if you are using something and you are converting from one kind of variable to another, you have to have it typecasted. If you are using any constant values anywhere, you have to typecast that as well. You just have to. It's not a choice even, because the compiler of Arduino is somewhat tricky, and at times it just gives you incorrect answers for not having the typecast. Going on for the math operators, so you basically have some mathematical operations. For example, you can say a is equal to b plus c, and you can also go like b minus c in a separate iteration. So the basic operators are plus, minus, multiplication, and division, and modulo as well. So these five are the most basic ones that you'll need to use. um, Other than that, you might have to use some logical operators, which are basically logical and logical or logical XOR. Now this has to do with the logic gates and the bits. So it is actually bitwise operation, and I'm sure that you will learn in this or some other class more about it. However, it is just good to know that there are operators like this as well. These operators are also useful in some cases where you have to write some specific conditions and you have to check for them. um, I think our next topic is loops and conditions anyways. So talking about conditions, so let's say you want to check, like you have one specific variable. Let's say you have unit 32t and variable 1. Okay, and let's say you also have variable 2, and they both have some kind of information stored in them. And if you want to check for them, you can go like if variable 1. Now if you want to check if it is exactly equal to as variable 2 or not, this is the operator. It is double equal signs back to back, and you just go like where 2, and if this condition is true, you write down here do this or do that or whatever you want. There are also other conditions. For example, if it is not equal to, so this will be the case where, so if I write something like this, I will always come inside this condition, because this condition will always be true unless these both variables hold exactly the same value. There are other things as well. For example, if you want to check two conditions at once, so you want to go like, okay, if variable 1 is not equal to variable 2, and I have also another condition that variable 3 has to be equal to variable 4. So in this case, what will happen is, let's say I have variable 1 equal to 1, variable 2 equal to 2, variable 3 equal to 5, and variable 4 equal to 5 as well. In this case, it will first check, okay, is variable 1 equal to variable 2 or not. It will say no, and therefore it is true that it does not match, so this condition is true. It will then check whether variable 3 and 4 are same. Since they are, this condition is also true, and this double AND sign means that it will perform a logical AND operation between the result of these two separate conditions. So if both of them are true, then and only then I will come in this if any of them is not true, I will not get inside this if loop. So no, not loop, but if statement. So, and you can do double ANDing or double OR, which basically says that if any of these two conditions are true, I want to go inside the if statement. um, so that's basically it for the conditions, except we also have, let's say, multiple if statements. So these are just cascading. If you want to check for multiple conditions regardless of what was the result of the previous one, then you go just like if and if and if and again. If you want to say something like, okay, if this condition is not true, I want to check for some other condition, then you can go else if, and you can put down your condition in here. So that basically tells the compiler that, okay, this is my condition number 1, and if this entirely is not is not um, satisfied, then go to the else if and check the next condition I have over here, and then you can just go like else, and you can say that, okay, none of the conditions match. And there is no rule in here, like you can have thousands of else if, and you can have if, and you can also have a nest of ifs. For example, I have this else if, I can also go inside and write another if, and another else if, another else. I can again have another if in here. So it's up to the complexity of your application and code, that how many of these and in which way would you want them or require to use them. But this is the basic idea of conditioning in C. And now to the final topic of loops. So loop is basically something that tells the code, or in this example Arduino, to keep doing something repeatedly until some specific point. So for example, I have, let's say, variable increment, let's say API, okay, and let me just clean this up a bit. Okay, I was just making sure that I am using those variables and they are not extra. Anyway, so if I want to do something in a loop, for example, I can say, okay, let's say I have some specific set of instructions, or C language coding lines that I want to execute, like say 100 times. So I'll just go like for I equal to 0. Now this is, so if you are going to use for loop, there will be three um, statements that you will have to pass as the argument. First will be the initial value of the individual variable that you're going to use. So in this case it's just I, so I will start from 0, and then I can go like I less than 100. So I will start from 0, and the for loop will keep on executing until I reaches 99, after which point it will just exit. And the final condition would be I plus plus. I plus plus basically means that when the loop is completed, increment the value of I by 1, and here I can have some of my code, and this code will get executed 100 times. You can do this the other way as well. For example, you can start with 100, you can go greater than 0, and you can decrement the value of I. But that is the basic idea behind the for loop, and you can use it in terms of different ways. There are also nested for loops. So this is one for loop, then I have some code, another for loop, another code, something like that. It's up to you. How do you want to write your logic, and how do you want to implement that? There are also while loops. They're pretty simple as well, because they just have one condition. For example, if I want to write the same code, I can just go like if while I less than 100, I'll have to initialize I over here, and then I can have some of my code in here, and I can finally go I plus equal to 1, or just I plus plus, whatever you want. So while loops are mostly useful when you have just one condition and you are not sure how many times it may occur, but you just want to keep executing the same loop again and again till that condition takes place. And yeah, so that's the basic while loop. There's one more loop. It's basically a while, but just a bit of modification, I'd say, which is do while loop. But you don't really need to go into the details of all of them, and I think you're good to go. As you can see, there are ways to use Arduino functions, for example A10, which is basically arc10, and it's so for example, this is the function that is provided by math.h, and if you want to know how to use that, then you can just go online and just type it in Arduino or something like that. It will get you right to the reference library, and you can see the function prototype right over here, and you will understand immediately that okay, you just have to enter one number and it will give you the answer in radians, because everything other is in the same unit as well. So yeah, I think that's about it. It could be tricky to begin with C language programming, especially if you haven't done anything in this particular area ever. But I hope that it won't be extremely like challenging for you, and hopefully you will enjoy it as well. All other TAs and I will be doing rounds in the lab, and if you have any queries, feel free to reach out to us. Thanks for watching, and see you next time.